Welcome to the Device Lab at Mankind Corporation in Danbury, Connecticut. My name's Chad Smutney, and these are my colleagues Spencer Kinsey and John Pokriva, two very smart guys that have helped us create a really awesome delivery system for the Afrezza inhalation powder. So today, I'm going to talk a little bit about how we simulate patients in the real world. What we have here is a little experiment that we'll get to watch and really provide some insights to how the powder is delivered. So the first thing we have is a piece of anatomy. This is an actual cast replica of an engineer. His name is Ben. Ben was cast. This was Ben's first cast. It was 1.0. It was rather alien-like. It kind of scared people. So we made 2.0, but inside Ben's head is the real anatomy. Ben was cast in an MRI and scanned for about 30 seconds. We took those scans and made a cast model. So we take the anatomy that we have from Ben and we link it to a piece of physiology in the background here. This big black box is called MIDAS, Mankind Inhalation Data Automated Simulator. Put a gold plate on it because we're engineers and we get a little geeky at times. But in MIDAS is a syringe pump. You see the green syringe pump here. And what it does is it pulls prescribed inhalation efforts. We can create pressure just like a human lung can. So we take the anatomy, take the physiology, we link it together, and we put the inhaler in line with it. And what we can do is we can actually watch an airway delivery of the inhalation powder. And that's what we're going to do first. This will provide some grounding and some foundation for you to better understand how the powder is delivered. So what we'll do is we'll take a loaded cartridge. The cartridge here contains about 7 milligrams, 6.7 milligrams of inhalation powder. It's very low density, highly dispersible. We're going to load that into the inhaler and we're going to drive it remotely and watch the powder get delivered. And then what I'm going to do is talk a little bit about the delivery and what differentiates Mankind from the rest of the world in terms of dry powders. So let's give it a whirl, John. Maybe cycle it. So a couple of things that you noticed there, the powder was moving through the airway model in what appears to be a very fast manner. In reality, the way that we deliver the powder is much slower than anybody else in the world. An asthma product, for example, like Advair, gets delivered at 90 to 120 liters per minute. Mankind delivers the powder at about 20 liters per minute. And that's because we're trying to get this powder deep into the peripheral aspects of the lung. And the way that we get the powder into the lung is by moving it slowly. By slowing it down, we're better able to navigate all of these pathways, all of these twists and turns. And we slow it down in a real simple way. We use a real simple concept called flow resistance that's embedded inside the inhaler. The inhaler is just a large resistive element. We'll run one more cycle. It's important to notice in the first probably 500 milliseconds of the inhalation effort, the powder has traversed the whole airway and is presented to the lung. Try cycling it again. What's interesting here is that in the 500 milliseconds, the powder activity is over. And importantly, it only takes about 350 to 500 milliliters of air. In a human lung, you have much more capacity to inhale. We're delivering the powder very early in the onset of the inhalation effort.